Elongation. This is last cross-like property which we are discussing now. What is elongation? The property of a mineral in which there is more growth in one direction as compared to other. That is, one direction is longer than other. You know that not every mineral is circular, neither it is in square shape. So it doesn't have all sides equal. Most minerals show growth more than more in one direction as compared to other direction. And this property of mineral is called as elongation. Elongation is property of mineral in which there is more growth in one direction as compared to other. That is, one direction is longer than other. Both isotropic and anisotropic mineral have property of elongation. It is constant property and have no relation with the rotation of stage. It is used for differentiation of anisotropic minerals having other properties similar. It is also used for determination of direction of slow ray and fast ray of minerals. Remember that elongation, the property of elongation can be possessed by both isotropic as well as anisotropic minerals. Second point in elongation is that elongation is a constant property. It has no relation with the rotation of stage. It is constant property and it doesn't change with the rotation of stage. It remains same. While we rotate the stage or we keep the stage constant or static. Elongation is used for differentiation of anisotropic minerals having other properties similar. As each mineral have its own distinct elongation, so with the help of elongation, we can differentiate minerals from one another. Elongation is also used for determination of direction of slow and fast ray of a mineral. Like compensation, elongation can also help us in determination of direction of slow and fast ray of a mineral. Now, types of elongation. There are two types of elongation. One is positive elongation or length slow elongation. What is positive elongation? When the slow ray of mineral is parallel to the length, that is longer direction or elongation of a mineral, the mineral is said to be exhibit positive elongation. If the slow ray of a mineral is parallel to the length of a mineral, it means that it is parallel to the longer direction or elongation of a mineral, then mineral is said to have positive elongation or it is said to have length slow elongation. On the other hand, in negative elongation or in length fast elongation, the slow ray of mineral is perpendicular to the length. It means that the slow ray of a mineral is perpendicular to the longer direction or elongation of a mineral. And such mineral in which slow ray is perpendicular to the length of mineral or it is perpendicular to the elongation of mineral, then such mineral is said to have negative elongation. How we determine that either it is positive elongation or either it is negative elongation? First step, we place the mineral grain with the marked elongation on the stage. सबसे पहले हम क्या करते हैं कि मिनरल ग्रेन को स्टेज पे रख लेते हैं और उसकी इलांगेशन चेक कर लेते हैं कि किस डायरेक्शन में है. आफ्टर सपोज दिस इज अ मिनरल ग्रेन as shown, this white is mineral grain and it has elongation in this direction. We have marked the elongation. Now after marking the elongation, we put the accessory plate as shown here in the second diagram. Now after accessory plate, before accessory plate, we also observe that whether interference color is of high order or it is of low order. As shown in this diagram, interference color is of first order gray. It means it is low order. Now after accessory plate insertion, we observe that either interference color has decreased or increased. Here you can observe that it has increased. First order gray interference color has changed to second order blue interference color with the insertion of interference color. So it means that addition compensation has occurred. So after the insertion of accessory or compensatory plate, if low order interference color changes to high order interference color, then it is addition compensation. And whenever addition compensation occurs, the slow ray of mineral is parallel to that of compensatory plate. In this first two diagrams, you can observe that addition compensation has occurred because first ray gray interference color has changed into second order blue interference color. It means that addition compensation has occurred. And we discussed that in addition compensation, slow ray direction of mineral grain tends to be parallel to the slow ray direction of compensatory plate. It means that the slow ray direction is parallel as compensatory plate has slow ray direction in this direction. It means that both slow rays of accessory plate as well as that of mineral grain are parallel to one another. So now you can see that slow ray direction is also parallel to the elongation of mineral. Such elongation in which slow ray is parallel to the length or elongation of mineral, then such elongation is termed as positive elongation, or it is called as length slow elongation. Now direction of slow ray is determined after insertion of a compensatory plate. Now if the direction of slow ray is parallel to the length of grain, then positive elongation. But if perpendicular, then negative elongation. Follow similar procedure for subtraction compensation. Here you can observe that both mineral and compensatory plate have slow ray direction similar. They are parallel to one another. So if slow ray direction is parallel to the elongation of mineral, then such elongation is positive elongation. But suppose if mineral has elongation in this direction, while slow ray direction is in this direction, as slow ray is parallel to the direction of slow ray shown on the accessory plate. So then such elongation is then termed as perpendicular elongation. Here you can observe in second diagram, this is example of subtraction compensation. Mineral grain show first order gray. Now it has reduced to the first order yellow color after insertion of accessory plate. Remember, if you check the interference color chart, first order yellow possesses low retardation as compared to the first order gray. That's why we say that first order yellow is of low order as compared to the first order gray. So here subtraction compensation has occurred. And in subtraction compensation, we have discussed that mineral grain, the slow ray direction of mineral grain tends to be parallel to that of accessory plate. Slow ray direction of mineral and slow ray direction of of accessory plate tends to be perpendicular to one another in subtraction compensation. हम पहले डिस्कस कर चुके हैं कि सबट्रैक्शन कंपेंसेशन में मिनरल का स्लो रे डायरेक्शन परपेंडिकुलर होता है एक्सेसिव प्लेट की स्लो रे डायरेक्शन का. So if subtraction compensation has occurred, it means that both are perpendicular to one another, and when perpendicular to one another means slow ray is in this direction, and when slowly in this direction, you can observe that now it is perpendicular, also perpendicular to the elongation of the mineral grain, and such elongation in its slow ray direction of mineral is perpendicular to the length of mineral grain. Such elongation is then called as negative elongation or length fast elongation. As why it is called as length fast elongation? Because fast ray direction of mineral is parallel to the slow ray direction of accessory plate. That's why negative elongation is also termed as length fast elongation. So dear students, this was all about cross-light properties of minerals. So if you have any question, you may ask, you may message me, or you may email me. Thank you all. Goodbye.